Welcome to my science tutorial again. In this video, we are looking at making ammonia in the industry, and that is what is known as the Haber process. The Haber process. Now, this involves the use of atmospheric nitrogen, which is going to react with hydrogen to give you ammonia. And of course, we need a catalyst, and the catalyst here is iron. Now, you might be wondering why it is important to study about the process of making ammonia. Ammonia has so many uses, which I'm going to put here. So uses of ammonia. So ammonia is used in making fertilizers. Used in making fertilizers. It is also used in making explosives. So it's used in making explosives. Explosives that contain TNT. And then it is used in making drugs. Drugs like sulfonamides, anti-malaria drugs, all these ones contains ammonia. And then it is also used in refrigeration. So let's see a refrigeration. Alright, so these are some of the uses of ammonia. There are many more. It is a very important chemical, and so it is important to study about how it is produced on a large scale. Now, for an industry to produce ammonia, what are some of the raw materials that they need? So let's talk about raw materials. So let me put here raw materials. Now, for the raw materials, you need air. So you might be wondering what the air is used for. The air gives us nitrogen. Remember, air contains about 71% of nitrogen, which is very important. So we get the nitrogen out of the air through what is known as liquefaction. So we get nitrogen from air, and we also need natural gas and steam. So natural gas and steam. Your guess is as good as mine. The natural gas gives us hydrogen. And how do we get the nitrogen out of the natural gas? Now, natural gas here is usually methane. Remember, methane has 1 carbon and 4 hydrogen atoms attached. So we get a hydrogen out through what is known as steam reforming, where we separate the hydrogen from the carbons in the methane. And one last thing that we need is the catalyst. Now, the catalyst here is iron. So iron is a catalyst that we have here. Now, another thing to look at is the condition. So what are the conditions that need to be put in place for us to get a good yield of ammonia in the industry? So conditions. Now, we need a temperature of 400 to 450 degrees Celsius. 400 to 450 degrees Celsius. We also need a pressure. Remember, we are dealing with gases, so we need pressure of 200 atm. 200 atm. And I've already mentioned the catalyst. So the catalyst is the iron. Alright, so these are the things that we need for us to be able to make ammonia. So let's look at the equation involved in this. Now we need nitrogen gas So nitrogen gas is going to be combining with hydrogen gas, and this is a reversible reaction to give us ammonia, NH3. This is ammonia. Now we need this to be in the ratio of 1:3, so I'm going to put 3 here, and I'm going to put 2 here. The enthalpy change here is minus delta H, which is telling us that the reaction is an exothermic process. That means that heat is given off in this reaction. Now let's look at this illustration. This illustration is going to show us what exactly is being done. So we have a chamber that has hydrogen gas, and we also have nitrogen gas in another chamber. So what is going to happen is these two gases are pressurized. They are pressurized into the second chamber here, which I'm going to call chamber A. So let's call that A. So over here we are going to be having a lot of nitrogen all around, as well as hydrogen. So these two are going to be combining to give us ammonia. So we are going to be having ammonia, NH3. This ammonia is going to be pressurized through this channel here into the second chamber, which I'm going to call B. So this chamber B, remember this is chamber A. Now over here we have high temperatures. So we have high temperatures here. To force, the temperature actually gives the gases the kinetic energy they need to collide to form the ammonia. So this chamber here has high temperatures, and so we are going to be forming ammonia, and we also have the catalyst, which is ion. So we have ion catalyst. All right, so now that this ammonia is being formed, we need something. Remember, it's still going to be in the gaseous form. So this chamber B has low temperatures. Which is going to cause it to condense and give us the liquid ammonia. So we have liquid ammonia in here. All right. Let me put that here, liquid ammonia. Good. So remember that the reaction is a reversible reaction, which means that it is possible to have some of the ammonia breaking down to give us nitrogen and hydrogen. That's why we have the double arrows here to show us that it is a reversible reaction. So what is going to happen is that even though we are having the condensation happening here, we are still going to have some hydrogen atoms and nitrogen atoms in here. So what happened to these free gases? Now these free gases are going to go through this channel back into the chamber A for recycling. So it doesn't really go wasted, it is recycled. Now I want us to have a look at the equation once again. The equation is nitrogen gas. I'm gonna clean this. So we have nitrogen gas combining with 3 moles of hydrogen gas in a reversible reaction, and then we have 2 moles of ammonia, NH3, and it's delta H minus delta H. So what are the factors we need to consider here if we want a good yield? Now, what you need to remember is that when gases such as this are being produced on a large scale, they look at what is known as economic yield, which means that they need to optimize the conditions so that they have a good yield and also to reduce cost. So according to the Chatterley's principle, if we have a reaction that is exothermic, like this one, which means that heat is being given off, what happens if we increase the temperature? If we increase the temperature, then the equilibrium is going to shift to the left in this particular case, which means that the ammonia is going to decompose to give us nitrogen and hydrogen. So what is important to do is to keep the temperature as low as possible if we need to get the ammonia. So the temperatures we say is 450 degrees Celsius. And what happened to the pressure? All right, according to the Chatterley's principle, the pressure, when we put a pressure into a reaction that involves gases, equilibrium actually shifts to the side with a lesser number of mole. So in this reaction, if you look at the reactant side, we have 1 mole of nitrogen gas, 3 moles of hydrogen gas, which is giving us a total of 4. Now on the product side, we only have 2 moles of ammonia. So what is going to happen if we increase the pressure? If we increase the pressure, we are going to have ammonia. That means that equilibrium will shift to the right. So that's a good thing for the industry, right? But then it is difficult to manage high pressures. So the industry needs to consider that in this reaction, the temperature is 450 and the pressure is kept at 200 atm. So that is manageable. These conditions actually give some yield of ammonia, but not as much as they could have gotten. So these are the conditions that you need to look at. These are the conditions that you consider when you are trying to produce ammonia on a large scale. Now, I hope that this video helps you, and good luck in your examination.